Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Harman Kardon HK3270. This is a repair for a family member. That's the reason I'm doing it. Normally I don't work on AVRs, but this one, it has developed a problem. Well, two problems actually. One of the problems is the remote does not turn the volume up and down. We're going to see about that. And then another problem is it's developed a crackly, fizzly, hissy, snappy, cracky, poppy sound in the left speaker. So let's turn this thing on. I got it connected to my power monitor. It's drawing 1.5 watts on standby because it does have internal transformer. So let's turn this thing on. And our power consumption shoots up to 32, 35. Oh, 29. And we're on auxiliary, so I should have a tone. I do. Left. Right. Okay, so that's working. Let's try this remote. Where's the remote receiver? That's the question. Does nothing. Does it have batteries in it? Yes, it does. So I'm just going to check the remote, and it is working. I don't know if you can see that. It is lighting up the so the remote is transmitting when I press the up and down volume. So it's not the remote. Okay, so we got to figure out why the remote is not working here. There's other, like if I go to phono, tape, so other remote functions work. Power, everything works except for the remote. So we'll have to investigate that. But I also want to investigate this noise from the left channel. So I'm going to leave this on. He says, you know, after you leave it on for a while, it starts to act up, like once it warms up. So I'll just leave it parked on the on position here for a while. And I'll just keep my ear open for noises. And then if it starts acting up, I'll bring it back in. So right off the bat, I noticed it's climbing up in power consumption. There's 38 watts. And it's slowly climbing up. You can see the digits there rising. Not sure what to make of that. So we might have a problem in the biasing, and it might be getting hot. Maybe that's why it's acting funny. So now we're at 39 watts. I'm going to leave this on for a while and see how it does. It might be just a matter of having it sit for too long. It gets too hot, and could be just the bias adjustment is out. But that wouldn't explain the noise. The scratchy, poppy, hissy noises that the amplifier is making. So I'm just going to let it go for a while. It's climbing up to 40 watts now, so this is going to get warm, and we'll see how it turns out. I'm just checking DC offset here, and I'm not really seeing anything. Let's see what we got here. 1 or 2 millivolts, mostly 0. This channel, we've got 6 or 7, which is perfectly normal, and we're power consumption is climbing up over 41 watts now. Right, I've had this thing on low volume tone for quite a few hours, and it hasn't misbehaved yet. Been tapping it. No luck. So I'm going to maybe take the top off, and then we'll troubleshoot this volume control issue while this is still playing. And maybe I can poke around at the boards. Maybe I can get something to misbehave. It might be a cracked solder. Who knows? Alright, so I have my probes on the back of the motor. And I'm going to activate the remote and watch the meter. When my probe came off. So this is probably your first check, just to see if the motor is getting any power. And if I press the down button, where is it? I'm getting any connection here. Press the up button. Where is this receiver on this thing? Okay, try that again. I'm getting voltage on the motor. Let me try getting a good connection here. Alright. So I'm getting a 1.5 volts, 2 volts, and if I go down, I should get a negative number. Down, I'm getting a positive number. I have a feeling this motor is kaput, but we don't know if the control is working. I was getting 2 volts before I turned the camera on, but let me see here. So it might be just a simple matter of removing that motor, disassembling and cleaning it. I have to tap it. It wouldn't be worn out. There's no way a motor like that can wear out because there's just not that much use on it. So we're going to remove all that, and then we have to scrutinize this motor. Alright, there's a connector here. This 5-pin connector, I hope you can see it. It's got DISP plus 5 volts, I think. VR LED. D is ground. VR up, VR down. I don't know if you can read those. But we're interested in the VR up and VR down. Now let's connect the voltmeter and we'll monitor those while we manipulate the remote. So here's a meter. And here I'm going to touch probe on VR down. Okay. Now I'm going to press the down button on the remote. And we got 5 volts. Let go of the button, 5 volts disappears. Okay, VR up. Pressing the up button on the remote. 5 volts. Remove the button and it disappears. Here's display, 5 volts, 5.2, that's normal. VR LED, the LED's lit up, so we have 5.11, that's normal. And D is our ground. There's our ground. So whatever problem, the signals are getting to this board. So whatever the problem is, either it's the chip or the motor. So we gotta diagnose this a little deeper. I have a feeling it's the motor, because if I go here, let's connect to this pin. Let's go down. We get 2.8 volts. I let go of the button. Press up. And we get 145 millivolts. Let's see here. The other motor connection. Press down. 143 millivolts. If I go up, I should get 2 point something. And there it is. Yeah, so this this motor controller chip is working. It's feeding voltages to the motor. The motor is not spinning. So that's our problem. So we got to take that motor apart and either clean it or repair it or do something. All right, here it is removed. I'm gonna remove the volume control assembly with the motor, and we're gonna test it out of the circuit. I don't know why the motor is not spinning. I might have to disassemble to figure that one out, but let's just take this out for now. And we'll see what we can do. Maybe it's just seized up from lack of use. If I jolt it with 12 volts, it might just wake up. But you can't be injecting voltages onto the motor because it's connected directly to the driver chip, and you don't want to backfeed any current into the driver chip because you'll blow it up. And it'll blow up good. You'll be looking for a new chip, so we got to remove it. Okay, I think I might be okay here. Let me have an inspect. I got some more. I think that's it. Okay. Here we go. Let's get some voltage on this. Okay, let's start with 3 volts. 2.8, good enough. Let's see if this thing works. It's drawing 100 milliamps, but it's not spinning. Reverse, 100 milliamps, not spinning. Is the motor seized up? Let's give it more juice. Let's go up to 4 volts. 4 volts. $150 milliamps, no spinny. Yeah, nothing. Let's keep going. Let's go up to 6 volts. It's going to have to move sooner or later, if it likes it or not. There we go. Spinning. And it's drawing about 80 milliamps. Can I go backwards? 50 milliamps. Is that all I needed? Let's go back down to 3 volts. .75. It's turning. It's moving really slow. You know what? I think these are difficult to open. But I can remove this, and this, and then it would separate the motor from the body. And then I could probably get in there and maybe lubricate it. I don't know what it needs. Like, it's working. Maybe it just needs to be worked back and forth a few times. See, now it's turning. About 40 milliamps at 3 volts. 2.75 volts. I'm going to just jack up the voltage to 10, and I'm going to zip it back and forth a bunch of times, and hopefully that will clean itself of anything wrong here. Okay. Does it need lube though? I don't think so. It's quiet. It was just stuck. Let's have a look inside. Okay. Here's our mechanism. It's all grease. Maybe it's just dried up grease. Spins really good at 10 volts, 50 milliamps. Let's turn it down. Three volts. .5 volts. .6. Yeah, I don't know what to make of this. Motor's working great. I think it was just maybe dried up grease. Let's turn it up a little. 1.6 volts. 2.7. Yeah, I think it's just a little bit of new grease and put it back together. Okay. I got junk on the end here I gotta clean off. Don't want to be putting trash into the gears. Okay. It's a little stiff. Let me take this gear out. Weight this one down. Might be just stiff grease. Okay. Put all new grease on this thing. Keep getting it out of frame here. Okay. All right. This goes like this. Okay. Okay. All right. That's greased already. And make sure our things are lined up the right way. Okay. Crush these down. All right. Let's see how it sounds now. .7 volts, 30 milliamps. It's running a lot smoother, less current. I think this is going to work. Okay, I'll put this back in. All right. This is a 5-volt regulator. And a little, here's our control chip. It's a BA6208 motor controller, I'm assuming. Bent pin. Okay. Looks good. All right, we're back together. Turn the power on. Remote. Up it goes. It's working. And down. Yeah, I think it was just stiff grease. It's working now. We need to sort that other problem, that scratchy noise that appears at random, so we're going to work on that next. Alrighty. Now, I had this connected on my listening bench for the last 3 days listening to it, and it behaved... Oh, did you hear that little pop? It behaved flawlessly, but this morning it started doing the pops and clicks, and I don't think it's got anything to do with a bad connection, because I've been poking my little plastic stick at, where is it? Been poking it at all these components, and I can't get it to make a noise. But it is making popping and noising, popping, clicking noises. It's going to wiggle everything around. But I have a feeling if I start heating up some of these transistors with my iron, it might just trigger some bad behavior. So we're going to do that. We're going to warm up some of these transistors. Let's start can hear it clicking. It's very faint. Do you hear that crackling? Just hang on a second. Okay, sorry about that. I had to deal with a runny nose. Okay, so let's go back to heating some of these up. Seemed like this one here had the most. Try heating this one up some more. So I get electrocuted. I can hear it clicking. Let's try some of these other ones. There we go. Can you hear that? It's coming live now. Might be one of these two. I'm in the area. Let's heat this one up. It could also be a cap, like a ceramic cap. I'll try heating some of these caps up. That one's kind of stable. Let's heat this other one up. Yeah, I don't know. I'm going to keep playing with this, see if I can zero in on what component is actually causing the crackling. I can heat, it says it, the client says it heats up, when it warms up it gets worse. So I'm assuming it's heat related. I'm going to get, let's just flood it with some heat. See how bad it gets. I got 110 degrees Celsius on this. That thing there, you hear it popping. Ooh, something back there. There she goes. She was not happy about that. Yeah, when I heat it up, it really could be a resistor too. And I heated it up back here. Let me try this again. I can't see anything back there though. That's the problem. What is back there? There's just a cap and some resistors. Might have a failing cap. So what I'm going to do is I'm going to pull this board out. So what I did is I removed the jumpers between the preamplifier and the main amplifier, and the noise is still there. That tells me that the power amplifier is the problem, not the preamp. So we can focus all our attention on that. And when I add heat, it just seems to get a lot louder. I just haven't nailed it down to where it is. It's still crackling. And there's something going on. Something going on in this left channel for sure. So what I'm going to do is I'm going to take the amplifier out of the unit, and then we can put it on the bench and we can start looking at it real close. I'm suspecting maybe a ceramic cap, but you know, that's a long shot. I'm guessing it's a transistor. Just trying to figure out which one it is. And my heating up transistors isn't really revealing the culprit. And I'm poking around here, and it could also be a resistor too. These little tiny resistors could have failed. But we also have a mix of old and new caps. We got these new ones here, these Nichicons, and these ones here, these are Samwas. These are the old original caps. I don't think a cap would be doing it though. Now, brute force method, what you can do is you can take components from one channel and swap it for the other channel and see if the noise goes with the component or if it stays in the channel. That's a last resort method that you can use. It'll get you there, but it's going to be a long, laborious process because you have to desolder the component, put it back in, solder it in, connect it all back up, test it, and see if it reacts or doesn't react. And then you have to do that for every component. That's a long process. It can be done, but it's try it better if you can just get it to reveal itself by mechanical probing or adding heat or cold. And so far, oops. Something in this corner. Okay, let's pull this out. Okay, now that I got this off, I can see the problem. We got a lot of cracks on these little resistors, jumper wires, capacitors. All these joints here are cracked. They have little rings around them. If I zoom in, maybe you can see one. Hope you can see this. Can you see the crack around this joint, for example? And then there's some other ones next to it that aren't that great. If I look around, I can see a bunch of these that have rings around them. Can't really do it through the viewfinder. But I'm going to resolder this board. This desperately needs... somebody soldered up the transistors, which is good. Some of these aren't soldered. These ones were. But I'm thinking it's a crack joint somewhere on this board that's causing us problems. See, that one doesn't look good either. So yeah, reflow this board. Let's see down here. Is that another one? No. Right here. It's hard to see with the flux on there. Yeah, I'm going to resolder this. I think that's our cause. cause of our problems. And I'm also going to replace the rest of these caps. I don't know why I left these ones. Probably because I didn't have them in stock. They're 330 at 63 volts. I can replace all these now. These were done. But there's still about 10 or 15 on here that could be changed. And I will do that, clean it, and we will reflow a lot of these joints. Alright, finished with this board, finished recapping, finished resoldering, cleaning, got it all looking good, and inspected. All the joints are there. All the joints are good. I have confidence that that was a cracked joint and not a defective transistor. It's really difficult to tell the difference between a cracked joint and a bum transistor. If they kind of exhibit the same crackle, pop, fizz, you know, kind of symptoms. But pretty sure I got it. We're going to put this back together and put it back in the receiver, and we'll test it. I'm just going to... Okay, I just heated this board up for the last 5 minutes, and absolute silence. I don't hear anything going on in that left channel anymore. So I'm going to assume it's done. I'll put this back together. Give it probably 2 or 3 days of listening, and we'll see if anything pops back. But I think we're good. I don't hear anything now. This is quite warm, and I think we solved the problem. Well, that's it for this one. That was an easy fix, easier than I thought. I thought it was a component, but it was a cracked solder. Pretty sure it was cracked solder. Now you can tell cracked solders and bum transistors exhibit the same kind of symptoms, so you got to be cautious of both, I guess. You got to pay attention to all the causes, I guess, what could cause it. But I think we got her done, and I think that's good. This will go back to the owner, and I don't know if you noticed this, but this was featured in episode 38 quite a while ago. So this has been in service for 2-3 years now, and that fault developed over time. It slowly crept up, but now we got it taken care of. We can go back, put this back in service, and it should last quite a while. So take care, thanks for watching, and we'll see you on the next one.